So today we're going to talk about surface arrays, and those came out quite a while ago. And it's one of those features where initially, when it was first announced, I was pretty excited because it was very cool. But then after reflecting, I wasn't really sure how often I would actually use this feature. Like it was cool and sexy, but when am I actually going to use it in my day-to-day life? And then as time has gone on, uh, it turns out that there's actually quite a few potential applications. So surface arrays are essentially you take a geometry and it gets repeated across a surface, as the name implies. It's an array onto a surface. And uh, the more obvious uses would be for creating some sort of uh, exotic architectural geometry. And it's just the kind of feature that an architecture student would just really sink their teeth into. Um, so I want to really focus in on some very prosaic, mundane kind of uses for this feature. And this is probably the one that I'm showing you on screen is probably the one of the more exotic ones. So this is actually, I've got a meeting on site on Friday to meet with the builder. We're going to be doing this little entry pavilion. And here's an example of how I would use a surface array. So we're going to take a sheet of 8 foot by 14 feet, quarter-inch steel. We're going to laser, or I'm sorry, water jet cut it, and then we'll go ahead and roll it and then weld it to this structure. And you can see that I've got all these perforations that I have selectively placed in the panel. And so this is a case of a really great application of perforated panel for a surface array. Now, most of the time when I'm doing a perforated panel, I might just resort to using a RenderWorks texture onto a solid surface. There are various RenderWorks textures that essentially mask out everything but the circle for a perforation. They come right out of the box. And that's a great way to do it. But in this case, I'm being selective about where the perforations go. So this isn't going to be a sort of a pre-bought perforated panel. We're going to cut all of those holes selectively. So let's just kind of get into it. So this is a solid subtraction. So if I double click on it and go and edit the solid, you'll be able to see how it's built. Close that, that we don't just yet. In fact, just go ahead and try to streamline some of this as much as possible. Okay, so let's turn off everything outside. So here again, oh, looks like I've got another subtraction. So let's double click on that, edit the solid. So you can see that I've got all of these little extrusions. All right. I've got all these little extrusions, right, that are being subtracted from this solid. And if I look at those extrusions, you can see that that is being reported as a surface array in the object info palette. So to make a surface array, you need two things. I'll double click on this to edit it further. You either need a base surface, and then you need the items that are being arrayed on the base surface. So let's look at that base surface because that's usually where I'm going to start. And in this case, what I have is a NURBS surface. So that's one of the legitimate allowable surfaces that you can use as an array. We'll look at some other options a little later. And so just to back up, I'm going to take a little detour and show you how I made this NURBS surface because it's really pretty easy. So let's back up a few steps here. Okay, group that. There we go. All right, so here's the geometry that we started with. So in this case, what I did is I just started with an extrude along path to make this shape, right? And if I double click, maybe if I just tunnel down, I can get back to it. That's a shell, okay. Yeah, so that'll work. I'll just do that. Just go ahead and I'm just going to drag duplicate this shell over here and just cut that. All right, so once I've got that geometry, right, in this case it's a shell, but it could be anything. Under my 3D palette, there's this extract feature. And so you can extract points along an edge or extract a single curve, so an edge in this case, or face is what I want to do. So you can see that this, as I'm hovering over this shell, it's highlighting that face. So I'll just click on it because I'm in the face mode and hit OK. And then you can see that it's given me a NURBS surface. I'm going to group it and go into the group just to be able to show it to you. So that's it. You know, however I get that geometry, whether it was an extrude along path or that was probably just a line that I made the profile of that roof plate steel and then extruded it and then shelled it to make it the correct thickness. But however you got there, I went ahead and extracted that face. So all that just to demonstrate how you would get the NURBS surface along which you're going to do the array. Let's go back to the array itself, edit the solid. Okay. So here's the array. And then if I double click on the array itself, I can, by default, again, the base surface, that's that curved NURBS surface that we are arraying onto. And then let's look at the array items. And if I select all and Control 6, you can see that I've got this 3D symbol that I've called hole 1 inch, very imaginatively named. And it's just, we go into it, you can see it's just a circle that I've extruded by an inch, just some arbitrary value. Needs to be thick enough to, enough of an extrusion to penetrate through this steel, the plate steel. And so it's a circle 1 inch diameter, extruded an inch, and then I made it into a symbol. And that's important, and I'll show you why it's important in a little bit. So if we look at the array settings, you can see that I can repeat the items along the array either by a fixed distance or by a number of repetitions. So I could decide that in the X direction, I wanted 20 repetitions, and in the Y direction, I wanted 30, or vice versa, whatever. In this case, I've made a fixed distance of 3 inches, and then it has an offset factor of 1, which means it's just going to be, there is no offset. But then in the Y direction, I also have a 3-inch offset, and I've given it a shift factor of 0.5. So that's what's giving me that sort of staggered rowing. If I made the shift factor 1, then they all line up. I could make it 1/3, and then they would be sort of this hexagonal pattern. And then when I get to the edge, I can tell the array whether I want to overlap the edge or trim it to the edge. So if it overlaps the edge, then that array is just going to go all the way over the edge, or trim. So it's going to snip off any of those arrayed items right when they get to the edge. Right. And then since it's a subtraction, of course, when I exit this subtraction, it'll take it a moment to calculate. But you can see it's as if I just like took a sheet of perforation and just cut right through some of the perforation holes. So surface array can generate a lot of repetitions, and you can see that it calculated those relatively quickly. Like that was pretty fast. So I'm gonna just, since we have time, going to play with some additional sort of features of that hole. So here's the surface array again. Let's change the distance to 2 inches and 2 inches, so a bit of a tighter weave. What else could I do here? I could rotate the pattern, say by 15 degrees. It's taken a minute to calculate. So now you can see it's kind of slightly skewed. All sorts of things I can do. And of course, it's not creeping up the side panels here because those are not part of the base surface. Only the rolled portion of the plate steel is part of the base surface.
Hey, Francois.
Yeah.
I'm missing a detail. You took a step that I'm not, I missed it. And so I understand how to do the duplicate array and what you're doing with the duplicate array, but you've also used that to subtract from a surface, and that's the part I didn't see.
Yeah, well, it's a surface array, not a duplicate array. I did misspeak, and
Excuse me. No, I meant surface
yeah.
array. So a surface array is this series of these circles just kind of sitting out in space, and then you use those circles to punch through, and that's the part I didn't get, the punch through part.
Yeah. So that was sort of already done. So here's I just basically
and
took this.
You don't need to jump ahead. I thought you already talked about
it's just I haven't. It's just a sidebar.
Okay.
Somewhere along the way, I lost my texture, which is fine. Yeah. So if I just paste this over here, right? I've got this shell, and I made it a shell. This is neither here nor there, so that if it turns out that a 1/4 inch steel is not appropriate, I don't have to redraw this extrusion. I can just change that to, say, 3/8, and it just got thicker.
So Francois, so you didn't need to take that 3D symbol and insert it somewhere in order to start it, where it is perpendicular to the plane of I noticed how the 3D symbol curves as the shell curves, right? I mean,
Correct.
It's always at a right angle to that.
Correct. Yeah, it knows to. It just knows to follow the surface. Yeah.
And does it use the center line? Because you had on the 3D symbol, you had moved it down 1/2 inch or whatever, right? So that the cutting plane was sort of right in the middle of
Correct.
the 3D. Okay, and is that what it uses then to align?
It uses if in the case of a symbol, it uses the center, the insertion point of the symbol.
Okay.
And in the case of geometry, it just plain old geometry, it uses the centroid, the geometric center.
I see. And it always starts at the center of the object that you're arraying on to?
Yes.
Okay. All right. Thank you.
Yeah.
And then you just take the surface array and as one thing, and then the base object as another thing, and you hit subtract solids. Is that what you do?
That's exactly what I did. Yep.
Perfect. So
Yep.
you have to explode the surface array and individually punch each one of those holes.
No. And that's the beauty of it. So after I've done that, if you know, if my contractor comes back and said, man, you got a lot of holes here. If we could just reduce the holes by 10%, it would cut the cost in half or whatever, then I can just easily make that change.
The other interesting thing about this is it's using the surface of the surface as the zero for the Z of the array. You know what because I mean, if you look at the Z horizontal of the drawing, the surface edges come up higher. Their Z at the edges of the curve is higher than 1 inch, but the array is using this, I want to say the surface of the surface as zero.
Correct. Yeah.
Might we
Right.
say
And
the
that's because,
top surface? The top
and that's
surface is
again,
that.
that's because if we look at the surface array and we edit it and we look at the array items, as Don pointed out, let's see if I can find the insertion point here. Yeah. So this is that 3D symbol. I've
Thought it had a negative ½ inch. Yeah, there you go.
Yeah.
Bottom Z is a negative half.
exactly. So that's why it's sort of centered on that surface, because
No,
it's
what
going
was
by its-
interesting was that the surface Z is changes along the curve when you compare it to the Z of the drawing or the layer. In other words, the edges curve up, so the Z of the is not really zero, but
Correct.
the objects being applied to it are using that as zero for themselves.
Yeah. We've bent the coordinate system.
Right.
Yeah. So let me go to kind of a slightly less exotic application here that where actually I break it down step by step and show you the process, which is really quite simple. So here's a situation where this is far less exotic.
So about the other project, for the holes, are they for rainwater to drain?
Yeah, it's
How do you do
it's
drainage? Just function.
yeah, it's just a gutter with holes in it to get the water into the basin.
Okay. So it's not okay. I see. It's based on the. All right. Thank you.
Yeah, sure. So here's another application. I've got, in this case, a rectangle that I'm going to use as my surface on which to array. It just so happens to be rotated in 3D space, but it's still a 2D object on a 3D plane. And then I've got two potential objects to array. I've got a little symbol, and then I have the same geometry as the symbol. You can see I was very meticulous about it. I made this little penny round tile and extruded a circle, and then I filleted the edge because I want it to look appropriately bumpy. So once again, I'll grab the rectangle, that's going to be the surface. I'll grab the symbol of the penny round that I've left white. And then under model, I just go create surface array. And then I get the same sort of dialog box that looks like what I was showing you earlier in the object info palette. I can change the origin factor, the rotation. I can make it a fixed distance. In this case, I'll just make it 1 1/8 inches. And then I'll have it trimmed to the edge. And I'll deselect display the base surface, though I could leave the base surface on. In fact, I'm going to cancel that. I'm going to change the fill color of the base surface to something gray. There we go. Let's do that again. See what happens. sorry, model, create surface array. And let's go. Well, it's taking a minute to calculate that. And let's go ahead and display the base surface. So now I've got a nice penny round backsplash. It's 18 inches tall, 4 or 5 feet long. And I've got grout color. So, you know, if I really wanted to get detailed with my interior elevation, I could go this route. But that's quite a common thing. And you can see that it's got some real thickness to it there, right? So maybe I want to go and edit that symbol. Let's go ahead and edit the 3D component. There it is. That's a fillet. So instead of making it 3/8 of an inch, I'll just make it an 8. It's still chamfered. I can give it a color. And then when I edit that, I think it's just calculating, thinking about it.
How does it know which side of the button to stick to the wall?
It's going by the Z.
Okay.
So, yeah.
Wherever the Z is what's going to be next to.
That's the insertion point. And then, so a positive extrusion from the Z and the button's going to be sticking out from the wall.
Okay.
A negative extrusion and it would stick into the wall. And again, it's taken a minute to calculate.
So Francois, if you were wanting to have like different colors of each of the little buttons on there, you would create a 3D symbol that had 2 or 3 colors in it or something like that?
Correct. Yeah, if I wanted to, I would need to sort of create a chunk, you know, like a sheet of tile and then replicate that.
Gotcha. All right, thanks.
All right, so let me go ahead. I'm going to revert to saved just because it's quicker than undoing everything. Let's see what happens when I do a surface array with the same geometry, but now it's not made into a symbol. Again, same spacing, same offset, the shift, trimming, all that. Everything's the same. So interesting. So I've got a fixed distance here. But if I go by number of repetitions, see if it'll. Say 30 repetitions. No, it's behaving. All right.
What do you mean when it says behaving, Francois? What would be
Well,
misbehaving?
earlier I was when I was testing this earlier, I was getting a result where the penny rounds were distorting. They were expanding to touch each other.
Yes, I've had that happen too.
But but I filed a bug about that, and I think they fixed it.
Sweet.
So that's great. Yeah, I'm happy about that. So another thing to know about surface arrays is you don't have to have like fancy 3D geometry. So let's make this 4 feet by 18 inches. Let's look right and rotate it left. So, there's again a piece of backsplash. This time I'm just going to draw a circle, give it a 1-inch diameter, and let's create a surface array. Same deal, it's highlighting the surface. So in this case, I just have a bunch of circles. They're just 2D circles. And you can see that they are kind of mushing here, right? They're not perfectly circular. If I change the distance to, say, 1 inch, so now they're starting to really distort, right? But and then if I space them way out, so you can see that that 2D geometry is sort of distorting itself, and it's not keeping as a perfect circle.
Is that still a bug?
I mean, not necessarily. But if I go ahead and I take that circle and I modify and create a symbol out of it.
Then it won't distort? Is that where we're heading here?
Yeah.
Great.
So now I've got this symbol, and let's do a surface array. So now as they're not stretching to fill, right? So it's not necessarily a bug. I just want you to be aware that if you just have raw geometry, it is liable to get distorted, which, that may be something that you want, right? But you don't necessarily need to go to all the trouble of having this long to generate 3D geometry. I mean, that's going to be very lovely for a rendering, right? But if all you're doing is just creating, say, some line work for interior elevations, and you want those interior elevations, say, in perspective, right? If it's just line work, you could just do a tile pattern and be done with it. But a surface array is another cool way to sort of hybridize your 2D and your 3D drawing tools. It's really starting to blur the line.
Well, and it seems like you have better control over where those tiles occur in space, as opposed to putting just a tile texture on it, or
yeah. A RenderWorks texture is going to be blurry and won't necessarily. And then if you wanted line work to go with it, you'd have to resort to a hatch, which would probably be very, sort of segmented.
right.
Yeah.
This is really
so
beautiful and elegant.
Here's another sort of application. This is similar to something we did in real life. So I just created an extrusion here for no particular reason. I'm going to use the taper face tool and just grab the top and then take this face and taper it back 10 degrees, say. And then I'll click on here and taper this face back 10 degrees. Okay. And then let's go ahead and do how did I do this? A fillet. And I think I did about a 2-foot radius. Is it this one? Yeah, I just filleted that by 2 feet. And then I'll fillet it again by 3 inches and just do these top edges. So that's how I got the shape below. Just wanted you to see how I did that, in case you were wondering. So here again, right, kind of like the original instance, I've got this filleted object, and I'll go ahead and extract some faces. Use the extract face. There's one, there's another, there's another. Hit return. Oh, you know what? I didn't hold down the shift key. There we go. Hit return. So here I've got 3 NURBS surfaces, right? So I can array to all of these, but at least with this particular geometry, I wasn't able to create it as a single NURBS surface. I tried under the 3D model, the 3D Power Pack. I tried a stitch and trim. There's probably some ways I could have messed with it some, but in any event,
add surface doesn't work.
I'm sorry?
Add surface doesn't work?
No, because it doesn't give me a NURBS.
Ah, okay.
I need a NURBS surface. So in this case, what I did is I did that same penny round and arrayed it. And so I'm going to have to manually adjust the shift. Oh, I'm sorry, the origin. You can see where I've been here. I've got an origin of just 0, 0. But on this one, I just played with the origin and I kind of stopped because I wasn't going to spend the whole day sort of aligning it, but by trial and error, just kind of playing with the origin until I could get something, that looks reasonably close. So there are some limitations, but yeah, probably spending more time to create this as a single NURBS. Maybe it's just an arc that's swept and then I derive a NURBS from that. Something to play around with. But this is, if you were using, say, penny round on a bench to get some texture or whatever, you could use a surface array for that. Here's another example where I may have like a little piece of furniture, like this drum. Right, that's a surface array. And the way I did that, do you have any say beaches? No, I don't. So the way I did that is I just drew some circles. Let's go ahead and just move that over. So I drew some circles. I just drew a circle and here's my circle. And then I'll just duplicate it and move it up 13 inches. And then I'll duplicate it and move it down 6.5 inches, and then change the diameter to 9, maybe? Sure. All right. And then I'll just take those 3 circles and modify, convert those to NURBS, ungroup it. So now I've got 3 NURBS curves, and then I'll just loft it. There's my loft surface. I'll just go from here to here to here, hit return. So it looks like that. Right. little hourglass drum shape. And then I've got a symbol in here. This piece of lattice. I'll just insert it in here just for fun. Not doing a good job. There it is. Okay. Cool. So you can see that I made the piece of lattice much longer than the drum. And so I'm just going to grab that and the surface, and under model, create surface array. I'll do, say, 10 repetitions just to start. And then for the edge condition, I'm going to trim it.
This is really well done.
So, right, I've got repetitions in both directions. So it's been a couple of days. So yeah, that works. With the drum, it's hard for me intuitively to know which is X and which is Y. Yeah, so that's not it. Let's do 10 of those. And then I'll just do one of these. And then I can just keep playing with the repetitions until I'm happy with them. Now, I did kind of cheat. So let me show you how I cheated. You'll notice that the 3D object, let's go ahead and I'm going to duplicate that. And we'll call it lattice vertical. And let's edit the lattice vertical component. So let's go to top plan view. So you can see that I've got this extrusion, but it's rotated relative to its Z. So let's just go ahead and rotate that back. Where are you, friend? No. The midpoint. So I'm rotating it so that it is vertical. Let's exit that symbol. And now let's we'll take these three. We'll make a new NURBS for it. Okay. And let's go ahead and insert, instead of lattice, let's insert lattice vertical. Now watch what happens. You won't like it. Same thing. I'll just do one repetition in 10. Or maybe I'll try 10 of both and see what happens. So not really my intention here. And so here again, here's another application where having a symbol is useful, right? Because when I got to this point, I mean, I was trying to get to this and I was getting that. And that's when I realized, oh, well, maybe the thing to do is I tried taking the pattern rotation and rotating it by, 15 degrees. But try as I might, I'll try again. Maybe I'll have better luck this time. That's very unusual. I mean, I'm getting some really cool things, right? But I'm not sure that that's really what I want. So I realized that rotating the pattern along the surface array was not going to get me what I wanted. And so this is again where having a symbol is useful. So there's the lattice vertical. And so I just went into the symbol and just selected it and rotated it basically in 30-degree increments or 15-degree increments. And so when I exited it, it recalculated it, and I could see, oh, I'm kind of getting closer to what I want. You know, not quite there yet. So once again, rotate it, say another 30 degrees. And so I'm, you know, basically getting closer and closer to what I want. And so if you look at the actual lattice piece that I used for this little demonstration, we go into the 3D view, you can see that I've rotated it quite significantly.
Francois, object information, object info palette for array doesn't show symbol name, correct?
It doesn't show the symbol name.
So we cannot change the symbol from here. We need
No, you would, if I wanted to change the symbol, like if I wanted to take this one, what I would need to do is go to the array, grab the base surface, copy it, paste it, and then start over. I think.
Could you not go in and grab the array instead of the base surface?
Oh, yeah. So you're right. I could take the array items, and that's that symbol, and I could replace it. Good point. I think this is what you were saying.
That's exactly what I was saying.
Yeah.
Or edit the symbol that you had that is there. In other words, when you go to the symbol from the array element, you could either pick a new element or edit the element that you're changing.
Correct. So yeah, and one of the reasons I was getting a funny, this was weird, is because I had rotated the pattern, hadn't rotated it back.
Right.
Once I do that, I'm actually pretty close here.
Very powerful.
And it's really fast. So, you know, again, this is like if we do interiors as well as architecture, and so sometimes there's some cool piece of furniture, and you know, we'd like to model it. And you know, if somebody's got a SketchUp model of it that you can download, I promise you it will have an insane number of facets. It will be a real drag. And I don't necessarily need like a completely, you know, of course there would be like a little extrusion at the top with a kind of a, you know, if this is like an ottoman, right? There'd be a base, and I didn't bother modeling all of that because this is the piece that's sort of interest here. But yeah, just a piece of furniture. And of course you might have two of these that were sort of interlocked, and so you could just double it up and then mirror in fact, I'll try that, see what happens if I've just doubled it. I'm going to take the array items. I don't think mirroring is going to do anything for me, but we'll see. Maybe. Oh yeah, it worked. Amazing. There we go.
So that's two surface arrays?
Yeah, and I just mirrored the arraying, the arrayed object. There you go. So that it goes, you know, the other way.
That's great. Thanks.
And then as we get even more prosaic, I mean, everybody's favorite, you know, chain link fence. So a real easy way to do a chain link fence is just to, in this case, I just took that little drawing and I just drew some 2D lines, right? So I made a symbol out of that. So I'll just take these two things and once again, surface array it. I think I set the spacing at 3 1/8. I mean, it's pure 2D, right? It doesn't really have any depth to it. But if you needed to model some chain link fence, it will show in 3D now, and certainly for hidden line references. And so, and you can see I can make this. Hopefully, I won't break the machine. This is just 3 feet by 6 feet, but let's make it 30 feet. I'm just on a laptop here, and it's just happily moving this around in 3D space. No problem. Again, if you're expecting to see the thickness of the bent wire, no. But let's go to a side view and rotate this left. There we go.
Francois, because it's 2D, the rendering time and horsepower is decreased, correct?
Yeah, it's just got a lot less to.
Well, could you? It won't rotate as well, but you could simulate the thickness by just changing the thickness of the line, question mark.
Sure. Yeah. In fact, I did change I do have a fairly heavy line weight on this.
Yeah.
So let's move that up 3 feet. I haven't tested this, so we'll see what happens when I pop a heliodon on here. It wants me to move to DC, but I'm in Austin. Right. So the 2D objects are not going to cast shadows. So, if you want your chain link fence to cast shadows, well.
Yeah, but you can see through it.
But you can, you can totally see through it. If I make the ground here, chartreuse. Ooh, that's hurting my eyes. It's a little bit easier. Yep.
Yeah.
And of course, you could just trace your fence with a polyline and in plan, and then extrude that, and then extract the faces, and all of that. So you can project a surface array of 2D geometry onto a NURBS surface. You don't, because you're projecting 2D geometry, that doesn't mean that you're limited to projecting onto a 2D surface. But then, I really wanted to get a little more exact. And so I went and took that same path of the wire and I dropped some 3D loci. And then I sort of, you can see, traced sort of this bent sort of shape. And then eventually, modeled this. Ooh. Right. So I can take this
and sell it.
and do an array out of that. I wonder if I made a symbol out of that. This was a couple of days ago. Let's see. Yeah, here we go.
That's very cool. With immense numbers of uses.
So now I just took these two wires and made them into a symbol. And then let's go ahead and do an array. I don't know why it drops a couple from the highlighting, but if you want some 3D chain link fence, shoot me an email. And it's remarkably fast at rendering that. And of course, as with the drum example, right, you can do something really fun. So you could take, here's just two NURBS curves. They're just lines. Here, I'll do it again. Let's go to top plan. I'll just draw a line here, and I'll draw a line there. And I'll just move that up, say 12 feet. Can't really see, but let's modify and convert that to a NURBS, and modify and convert that to a NURBS. So there they are. And once again, I'll loft from here to there, hit return. I don't need to keep the curves. And if I render it, you can see I've got this warped surface, right? And that's a NURBS surface, so it's legit. Way down here is my little chain link symbol. So I'll select those two and do a surface array. Same spacing. Didn't take long to calculate that. Took a lot longer to do the penny rounds. I guess the fillets were, all right, it's taking a minute there. So if you needed to warp some chain link, and you can see it's, as it's warping, it's kind of, I need to work on that symbol a little bit. But anyway, you get the idea. So it doesn't all have to be super exotic geometry. I think that's pretty much what I have. And look, somebody have other questions.
It's really cool.
No, very cool. They did a good job on this one.
Yeah, and and it's been around for a long time. I think, again, as I said at the beginning, you play with it and you're like, well, this is really cool, but how would I really use this in my sort of, day-to-day pedestrian kind of existence? And I think these are some examples. I mean, being able to draw chain link fences in your model in a way that doesn't overwhelm your processor and actually is sort of useful, sure. I mean, why not? There was a time when I was on a chain link fetish and was, using them for things I probably wouldn't use them today, but anyway, that's okay. You do hog panel, whatever.
Francois, if you had used the 2D symbol on what you just arrayed there, the curved lofted surface, then it probably wouldn't have had the issues that the 3D in terms of matching up.
No, I think that's just I just need to kind of fine tune my geometry, but let's take the array items, and there it is. So I'll just delete that and insert. And exit. So I just chose a really extreme curvature.
Gotcha.
Could you use this tool to create a clay tile roof?
Yeah, I think so.
Is there a way to model a clay tile roof?
Yeah.
Because the texture for that does not work very well.
Yeah.
It does not look realistic.
Yeah. Yeah, that would be a great application. I wish I'd thought of that. because I love those. So yeah, so if I have a surface that's a little less intense. Yeah, see, I mean, there's a little bit of a gap there, but that looks pretty credible. I'd think that was real. Dick, that's a great suggestion, the clay tile roof. I'll play with that in my spare time.
Okay, that would be
You
great.
probably want to model your clay tile in a way where you're only modeling the part that's visible, right?
Right.
This is
You could
gonna
even
go ahead.
no, go ahead.
No, I was just gonna say this is gonna destroy the first free afternoon I have.
Yeah, you could even just go ahead and model your roof with the roof tool, right? And then use the extract
Right.
3D tool to just extract each face, and it'll come off as a NURBS, and then boom, you could just throw your tile on there. I think that would work. I'll play with that.
We're seeing you demonstrate it sometimes. But I'll try it on my own too.
But Francois, it needs to be a NURB surface that you're arraying on, correct?
It could be a rectangle, could be doesn't have to be a NURBS.
Okay.
Yeah, it can't be a generic solid. It can't be a solid. It needs to be something that is something that has a thickness of 0.
Gotcha.
Or no thickness is probably a better way of putting it.
Well, that's strange because in your very first example with that curved steel,
yeah,
that seemed to have a thickness.
Nope. The thing that I subtracted from that has a thickness.
Yes.
But you'll remember I extracted the NURB surface of the top surface of the curve.
Ah, okay.
And I used that as my array surface.
Right. And then
and then subtracted solids to get the
I'm not sure you got the surface yet. Did you just leave it there? So, I mean, if you're putting the array on the surface,
yeah, so if we look at it, well, there it is right there.
now that's
So I've got 2 objects here. I've got a shell, and then I have the array.
But the shell has no thickness? Question mark?
No, the shell has thickness. It has a 3/8 of an inch thickness.
Right.
Yeah, let's try it again. So here's the shell. So I'm going to use the extract surface, and I'm going to steal the top face of the shell. It leaves the shell alone. It just kind of clones that top face.
So they're in the same place.
Yeah.
Right.
And then I'll go ahead and insert my where's my hole?
There, I think it was down right there. Hole.
There it is. I'll just insert my hole here. So now I've got 2 objects selected, a 3D symbol, the 1-inch hole, and then the NURB surface. Right. And then surface array.
And you still have the shell there? Question mark?
Correct. Yeah, there's the shell. And there's
no,
the surface array.
That's the surface from which you extracted the shell. I mean, created the shell. You understand I mean, that sheet metal there is a 3D object.
It is.
And the portion of it you selected and said, make a surface that I can do something with.
Yeah, that I
So,
use the extract on.
right.
But the
And
extract is non-destructive. The extract didn't do anything to the original
right.
shell.
Then there is another curved object there. There is the original one from which you extracted the surface. Then there is the surface, and then there is the array.
Yeah,
Yes?
yeah. So
No?
if I take the shell and I edit the solid, it'll take me back. This is the thing that I made the shell from. It's um, it's just this. Basically, I just drew this.
Now, what I'm confused about is you made the curved metal, and
Yes,
you didn't have anything, and now you needed a surface, a 3D NURBS surface upon which to make the array, and you couldn't
yes,
do it on the metal because the metal has thickness, so you extracted the surface.
correct,
At the moment before you did the array thing, at the moment you extracted the surface, you had the metal with thickness and you had the surface, two different things.
correct.
And then you made the array on the surface, which was in the same place as your metal,
Yes.
and you laid the array on that. Fine. Now what we
Yeah.
have is the metal, the surface upon which you put the array, and the array.
No, the surface that I put that upon which I put the array is
Uh-huh.
sucked up. It's hoovered up into the array.
Ah, okay.
I'll show you because let me move it. I'll move it down
That was
4 feet, and
my
then I'll display it. So
confusion.
there it is, but I'm
Ah,
hiding it.
right. Okay. And then if you were to subtract that, um, it would put holes in that surface, but not in the metal. In other words, right now, if you subtract,
If
you
I
get
subtract
holes.
the rusted and the array,
Uh-huh.
and I model and subtract surface, subtract solids.
Uh-huh. The question is it putting it seems it would put holes in the metal and the surface, but the surface wouldn't but the surface is part of the array.
Correct.
But it's not a real thing. Question mark. I mean, if you I'm wondering where the surface went.
Yeah, it's part of the array.
Right, but why doesn't, if it's part of the array and you subtract solids, why doesn't it subtract its entire rectangle from your steel and disappear? I mean, it seems to be like a virtual thing that doesn't
Yeah, I
really
mean, well, it
exist.
also has no thickness, right? So maybe it is subtracting, but it's subtracting with no
Ah,
thickness.
okay. All right. Even if
Yeah,
it isn't, I can go with that as an explanation. Fine.
yeah.
Yeah.
And then, yeah, I think inside the array items to get it to make a clean insertion, I think I moved this down or set a 0.
Right. Yeah. Yeah. Half an inch. Right.
Yeah, yeah. So that it's going punching all the way through and not just making.
Right.
I was going to make a golf ball for today's demonstration, but that did not turn out well. So
Ah,
we'll skip that. Yeah, yeah. So the I guess the way of thinking about it, Samuel, is that the surface part of surface array is it's kind of like what you were saying earlier. It's like a localized geometric plane on which organizes the array, but it's not really
an
um,
object.
a 3D something that you can subtract or add from. Doesn't seem to be anyway.
Yeah. But it's something you can select, so it's very strange.
NURBS are weird, you know. What can I say?
Oh,
So yeah, yes.
How did you make the original shell into 3 different parts? Did you trim it, or did you make it from 3 separate surfaces?
To make the original shell, I did
The bent
this.
metal.
Yeah, I did this. I'm just going to do it quick and dirty. I picked I didn't really freehand it. I just, I drew this shape and I extruded it. Let's give it some solidity. Okay. And then I did a fillet, say a 3-foot radius, and I just selected this. So that gave me that curve. The reason I like the fillet is I can sort of play with the radius until I get something that I'm happy with. Okay, there we go. And then I'll just extract. Oh no, and then I just shell. Yep, that's it. I don't have to extract anything. I can just shell. Now in this case, I'm going to shell faces. Yep, that's right. So I'm going to click here. Oh, that's weird. Do an inch. Oh, I'm holding down the shift key, what you may not be able to see. And I'm holding down the option key to get these far faces. So I'm basically selecting every face. What happened? Oh yeah, I missed some of them. Let's try that again. So shell. This one, and this one, and this one, and then this one in the back, and then this one on the bottom. So when you hold down the shift key and select multiple faces on a solid, those solids are going to be hollowed out as part of the shell. So in the case of this prism, I, selected everything, every face except the bottom face. And so that is what remains. Does that answer your question?
Yes, I just missed how it went from one plane to 3 when you did the fillet.
3 surfaces when you did the fillet.
Sure. All right, so we've got a fillet here.
Before you have the fillet, it was just 1 surface.
Yeah, it's 2. And so the fillet is just this edge between these 2 angled planes. So when I click on that and hit return, then it makes a radius. It makes a fillet.
All right, I see. Thank you.
And then I play with that, right, radius until I get one that I'm happy with.
Now, conceivably, you could have made a 2D polyline construction with that curve in it and extruded that.
And then shelled that. Yes.
Yeah, right. Okay.
Yeah. As is the case in Vectorworks, there's like 12 different ways to do something.
No, in fact, I like the fillet more. I just would have always done that with a polyline and played with the either the Bezier or the curve, but this is better or easier for me anyway. I like it.
It allows you to sort of explore the geometry a little more viscerally because it's 3D as opposed to just an abstract elevation. So in that sense, yeah.
So Francois, I'm sorry, but I missed one detail. Could you go just show us again how you select all the edges to get this to shell and just
Sure.
get those three surfaces?
Yeah. So I'm going to be in perspective here. I
Yeah,
find it a little
perfect.
bit easier.
Okay.
And we'll go to wireframe.
No,
Might
oh
make it
man,
more obvious.
all
So
right.
then I'll shell. So I'm clicking here. If I'm hovering over here, I'm holding down the shift key, which you can't see, which is weird because I thought
No, if you just say it, it'll do what it's supposed to do.
so I'm holding down the shift key.
Yes.
And so that's and then but now it wants to grab this top face. That's fine. So if I hold down the option key, then you see now I'm holding down the option key and the shift key. So it's grabbing
I got it.
that back face. And now I'm holding down the option key and the shift key, and it's getting the bottom.
Yeah.
And now I'm letting go of the option key, but still holding on to the shift key, and it's giving me the top. So now it has every face except the three that I want, and I hit return. And Bob's your uncle, as they say.
Well, how cool is that? Thank you. That's
so cool.
All
After
right.
10 years, keep learning the basics.
Exactly. There's so much more to learn. Well, listen, how do you think I learned? By like preparing for these meetings, like just getting ready for this. You learn. So yeah, next time we meet, we'll talk about some of the 2028 features. I'm super excited about depth queuing and door and window assemblies, and so it'll be fun. See you all next month.